Assalamualaikum and hi everyone. My name is Masniyati Binti Ahmad Saufi. My supervisor is Puan Sita Fawati Binti Jamaluddin. Today I would like to present my final year project with the title The Evaluation of Efficiency in Hydraulic Ram Pump by using Artificial Bee Colonial Algorithm. The first chapter will explain about background of my study. The first one about a hydraulic ram pump. This pump is a device that can raise water to higher level without use of any external energy. It has existed for more than 200 years. It is a type of renewable energy that works without a source, and it provides energy from water power. The special features of this pump is very environmentally friendly, and the pump made up of three major components, which are a waste valve, delivery valve, and a chamber. There are three phases will occur. The first phase, water flows from the source to the hydraulic ram pump, carrying its kinetic energy and exiting at the waste valve. This will cause a water hammer effect in the entire water flow, which opens the delivery valve. The next phase begins when the delivery valve is pushed to the top and the air chamber connected to it begins to fill with the water. At the same time, pressuring the air inside the air chamber and converting all that kinetic energy into accumulated potential energy. And the last phase, within a short period, the accumulated potential energy in the form of pressure air inside the chamber begin to overwhelm the kinetic energy carried by the water. It closes the delivery valve while delivering water to its predetermined height within the air chamber via the output pipe. Next, background of study about artificial bee colonial algorithm. ABC algorithm is a swarm-based meta-heuristic for solving real-world and optimizing numeric problems. It was inspired by the intelligent behavior of honeybees swarm in search of food source. There are three types of bees, which are employed bees, onlooker bees, and scout bees. ABC describes two leading modes of behavior, which is give the result in positive feedback and negative feedback. Next problem statement. In the agriculture sector in this century, many pumping systems are powered by household electricity. The cost of electricity increases as its daily use is required. Second, water must be supplied in various locations away from water source, and this causes the flow to be unstable in the pipeline. Next, objectives. The main objective of this study is to improve the efficiency of hydraulic ram pump by using the artificial bee colonial algorithm. The specific objectives are to determine the stable flow rate of water, to determine the minimum of delivery head, and to minimize the size of pressure chamber. Next, scope of study. The study involves some of parameters of hydraulic ram pump, which include the flow rate of water, the measurement of the delivery head, and the size of pressure chamber from the secondary data obtained. Significance of this study. The use of water resource and the costly tank can be replaced with hydraulic ram pump, which is less expensive and more environmentally friendly. This study helped to improve the efficiency of the pump. Most importantly, the efficiency of the hydraulic ram pump will help the agriculture sector to operate very well. The first one about hydraulic ram pump. The manual ram pump was invented by Whitehurst in 1797. There were theoretical attempts that failed to explain the performance of the pump until Zhukovsky provided his explanation in 1898. In 1933, O'Brien and Gosling presented the first rational theoretical analysis of ram pump. In the ram pump, they assumed four time phases. According to their research, the pumping stage occurs when the impulse valve is closed, followed by a water hammer and shock wave propagation in the dry pipe. Lansford and Dugan also implied there are 6 phases in the ram pump. They modified O'Brien and Gosling theory by conducting experiment and theoretical investigation to determine the rate of pumping and wasting for any condition of operation. Next, artificial bee colonial algorithm. In 2020, Mohammad Saleh et al. Performed a component-wise analysis of the ABC algorithm using diversity measurement. The analysis uncovered that the scout bees component was ineffectual and the onlooker bees component had destitute worldwide searchability. To assess their performance, Scoutless ABC is utilized on the parameter preparing issue of fluffy neural arrangement for solving a classification issues. According to Hussein et al. In 2017, found ABC has an efficient optimizer for fluffy neural organized as compared to particle swarm optimization and mind-bias calculation. Method of data collection. Data collection uses secondary data from a journal with the title The Design and Analysis of Hydraulic Ram Pump System. The data collected is related to hydraulic ram pump parameters such as pressure chamber diameter, delivery head, and volumetric flow rate. And on the other side, about method of data analysis. The data analysis method was used quantitative data analysis technique. Next, artificial bee colony algorithm, ABC. The artificial bee colony is an optimization technique that mimics a foraging behavior of honeybees. A swarm of honeybees work together to complete tasks and achieve a good result. The procedure starts with the employed bees being placed on flower patches to determine the amount of nectar. Then, onlooker bees will move to promising location shared by employed bees and stay in areas with a high amount of nectar. Otherwise, scout bee will replace poor bees to find unexplored areas. This process will be repeated until the maximum number of iterations is reached. Model validation. The validity determined by make comparison result of the percentage efficiency difference between the method choose ABC algorithm and simulation analysis by using a formula below. The highest volumetric flow rate represents the highest percentage efficiency of the hydraulic ram pump. If the volumetric flow rate is higher, it shows that the ABC algorithm is better in solving the efficiency of the hydraulic ram pump because has a high difference of percentage and vice versa. Data collection. Data acquisition was available in the three tested design of the hydraulic ram pump. The different characteristics are the minimum delivery head, pressure chamber diameter, and its volume size, as shown in the table below. This will be taken into account to check the efficiency of the pump system. As we can see, design 3 has the biggest diameter of pressure chamber among all the design, and the minimum head delivery size for design 1 is the largest. Artificial bee colony algorithm. Under chapter result and discussion, I will go through how this algorithm works in order to find a solution for this project. The process is divided into 4 phases. The first one, initialization phase. All vectors of the 4 sources population start initialized with the scout bees with 100 population size and having new variables that must be optimized. Second, employed bees phase. Employed bees hunt for new food source and recognize that there are additional nectars nearby and the goodness of feed is determined. Third, onlooker bees phase. Onlooker bees select food sources based on probability values calculated using the fitness value of employed bees. And the last one, scout bees phase. The scout bees who choose their food sources will start looking for new solution to problems that the employed bees failed to solve previously. Flow rate. Pump's efficiency can be obtained based on the flow rate. The higher the flow rate, the higher the efficiency of the pump. Based on the formula given, the speed of revolution and whatever is taken into account to determine the flow rate. The high level of the flow rate depends on the height of the speed of revolution. Here the speed of revolution for each design after do some calculation. Model validation. By using ABC algorithm, the best solution are found. The result obtained shows the same value as the simulation analysis approach, which means the efficiency of the pump is 15%. It indicates that volumetric flow rate achieved by using this algorithm does not increase or decrease. So, the conclusion can be made. The best design was design 1. The result revealed that the minimum measurement of the pressure chamber give the hydraulic ram pump efficiency. As recommendation, the hydraulic ram pump should design in many types of design with different value parameters to get the maximum efficiency. So, it's necessary to study the factors that highly influence the characteristic of an effective hydraulic ram pump.